Dear students, I am Dr. Shikha Pandey, Associate Professor from Institute of Aeronautical Engineering. So today I will discuss about the landfill technology. Means what are the current practices that will be used in the landfill technology from now onwards, because of the leachate generation, the advancement of this landfill technology is very high. The technology is very much improved. So first of all, we'll understand the basic about the leachate. What is the leachate and how this leachate can be defined? So this leachate is a kind of contaminants that can be generated by the percolating of liquid from the solid waste from the landfill sites. So from the landfill site, many type of waste will be there. So during the rainy season, that will start percolating. The liquid will start percolating from the solid waste, and it is going to be enters to the either groundwater or to the subsurface areas. So this percolating solid waste will be having very toxic in nature. So this leachate is very toxic in nature because they are having very high concentration of ammonia. So leachate is a liquid that drains or leaches from the landfill, and it is generally varies widely in composition regarding the age of the landfill and the types of the waste that it will contain. And usually it contains both dissolved and suspended materials. Usually it contains some dissolved material and some suspended material. So we will discuss about the technology, because nowadays most of in every big city, landfill is there in the outskirts of city. So and the leachate generation from the landfill is very common problems nowadays. So to sort out these problems, for the treatment of landfill, I have discussed about like two methods has been used, like aerobic methods and anaerobic methods. Like activated sludge system will be used, trickling filter will be used, or sometimes a leachate pond will be there, that is called as aerated lagoons. So this type of techniques is now has been changed into some technologies. So technologies are the next generation landfills. Today we'll discuss about some of the technology that has been added to the landfills. So the next generation, this type of technology can be used in the landfills. A bioreactor landfill operates to rapidly transform and degrade the organic waste. So the bioreactor in the landfill are like it will operate to the rapidly transform and degrade some organic waste. The increase in waste degradation and stabilization through liquid addition or air, or sometimes it will be enhance the microbial process. So this type of technology is like the bioreactor. It is a kind of bioreactor which landfill is operating by rapidly transforming and degrading some organic waste, and the increase in waste degradation and stabilization by the addition of some liquid or air, or sometimes it is going to enhance the microbial process. So you can see that this is the picture of anaerobic bioreactors. This anaerobic bioreactor is like rapidly transforming and degrading all the organic waste. So the increase in waste degradation rate and stabilization through liquid addition or air addition, it is going to enhance the microbial process. So aerobic and anaerobic. So aerobic bioreactors are in the landfills is using, and it is removing the leachates from the bottom and recirculating it to the landfills in a controlled manner. So this what it is doing, this aerobic reactor will remove the leachate from the bottom, and then it will recirculate into the landfills in a corrected manner. Next is the air injection into the waste mass using vertical or horizontal wells to enhance the aerobic activity. So in air injection to the waste mass is like using some vertical and horizontal wells will be there, and they are going to enhance the aerobic activity. So what is the anaerobic activity? So the anaerobic bioreactors are the landfill is a moisture is added to the waste mass in the form of recirculated leachates. So this aerobic and both aerobic is working on the same principle. Aerobic and anaerobic both are working on the same principle by adding leachate is removed, removed from the bottom and recirculated to the landfill, then again what it will do, it will be recirculated to the landfill, and the air injection into the waste mass using vertical and horizontal valves will be injected to enhance the aerobic activity. So this anaerobic bioreactor landfill, moisture is added to the waste mass in the form of recirculated leachates. Biodegradation can occur in the absence of oxygen, so that's why this process is called as anaerobic and produces some landfill gas. Landfill gas is methane and CO2. Okay, and they mostly primarily methane. It can be captured to minimize the greenhouse gas emission and can be used for the energy projects. So in this technology, this is a landfill gas, which is methane. That methane can be captured, or because to stop the emission of this gas, because this methane is a very high potential of greenhouse gases. This methane can act as a very high potential of greenhouse gases. So this can be used for the energy project, or either we can use this for some projects, or we can collect this methane into a methane collection chamber. Next is the hybrid type of reactor. So hybrid type of reactor will involve both the process, like aerobic process as well as anaerobic process. So the hybrid bioreactor landfill will excrete waste degradation by employing a sequential aerobic and anaerobic treatment. This hybrid bioreactor of the landfill will accelerate the waste degradation by employing a sequential aerobic and aerobic treatment as well as anaerobic treatment to rapidly degrades organics, so that it will rapidly, the organics can be reduced, the organics that is present on the leachate, because leachate will have mostly organics will be there and suspended solids will be there. So these two can be reduced. This degrade organics in the upper section of the landfill and collects gases from the lower section. So this aerobic and anaerobic treatment to the rapidly degrades organics. Rapidly it is going to degrade the organics in the upper section of the landfill, and it is going to collect gas from the lower section. Operation as a hybrid results in the earlier onset of methanogenesis compared to aerobic landfills. So this hybrid, in hybrid process, like aerobic and anaerobic both are involved. Aerobic and anaerobic both are involved. So the operation as a hybrid results in the earliest onset of methanogenesis, and by incorporating nitrogen cycle control, the ammonia can be partially treated to create nitrated leachate. So by incorporating the nitrogen cycle control, first what is there, we will incorporate the nitrogen cycle control. So in this way, the ammonia can be partially treated to create nitrated leachate. This can be partially treated to create the nitrate leachate, which is a leachate treated to convert ammonia to nitrate. Then this leachate can be treated. So with treatment, that ammonia can be converted to nitrate. You can see this is ammonia can be converted to the nitrate. The nitrated leachate serves as an electron donor, much the same way oxygen or air would be in aerobic landfill. So this nitrated leachate can act as an electron donor, and it can be treated in the same way oxygen or air would in the anaerobic landfills. So you can see that this is the picturization of this hybrid bioreactor. We are discussing about the technological improvement in the landfills. So for this type of hybrid bioreactors has been proposed. This hybrid bioreactor will involves both type of process, aerobic process as well as anaerobic process. So you can see that this green color is the leachate generation and liquid addition. Then yellow color will show the collection of gas, collection of leachates from the landfill site, and that can be used for the gas collection for the generate electricity, and then continuous the electricity and some works. So this methane can be very much useful. So to avoid methane, to avoid the greenhouse gas, production of greenhouse gas, production of greenhouse gas, methane can be generated. That so it will be generated with some leachate or liquid addition will be there, and yellow color is the gas collection. So next, leachate nitrification treatment. You can see this is the chambers where the nitrification treatment will be going on. In this chamber, the nitrification treatment is going on. This nitrification treatment will convert to the gas collection system, and in this way you can utilize this methane for the energy production, for the electricity generation, for everything. So this is a bioreactor landfill. So at a minimum, leachate is injected into the bioreactor. So into the bioreactor, very less amount of leachate will be injected, and it is going to stimulate the natural biodegradation process. So it will stimulate, it will stop, or you can say it can hamper the biodegradation process. And this bioreactor often needs other liquids such as like storm water, wastewater, and wastewater treatment plants, some plant sludge to supplement the leachates. Next is the moisture content is the single most important factor that is going to promote the accelerated decomposition. Like approximately 35 to 65% of optimum moisture content should be maintained. So moisture content should be maintained like 35 to 65%. 35 to 65% of optimum moisture content should be maintained. 35 to 65% of optimum moisture content, MC, is the moisture content should be maintained. The effects of bioreactor is that it produces landfill gas like methane in an anaerobic unit. It produces landfill gases like methane into the anaerobic unit and at an earlier stage in the landfill's life, and at an overall much higher rates of generation than traditional landfill. So this anaerobic unit at a very earlier stage in the landfill's life, and the overall very much higher rate of generation than traditional landfill. So the effects of bioreactor is that it produces some landfill gas like methane, and it acts as an anaerobic unit at a very earlier stage in the landfill's life at an overall much higher rate of generation than the traditional landfills. So these are the mechanisms. What are this landfill gas emission are governed by gas generation mechanism and gas transport mechanism. LFG is the landfill gas emission, landfill gas. This is called as LFG. So this is the mechanism. It will be governed by gas generation mechanism and gas transport mechanism. Gas generation or either gas transport. So there are three causes of this LFG, landfill gas generation. First is the volatilization, then biological decomposition, then chemical reaction. So three primary cause by which this landfill generation, these gases has been generated into the landfill. So first we will discuss about the volatilization. So volatilization will involve the organic compounds in the landfill. This volatilization is involved the production of gases inside the landfill until the equilibrium vapor concentration is reached. Until some equilibrium condition can be reached into the landfill. So this is from there this organic compounds has been released, and this process is accelerated when the biological activity increases the temperature of the waste mass and rate at which compounds volatilize. The process is basically accelerated with some biological activity, and it is going to increase the temperature of the waste. It is going to increase the temperature of the waste mass and rate at which the compounds volatilize, and it will depends on their physical and chemical property. So this volatilization property process will involve the escalated process where the biological activity increases the temperature of the waste Mass and rate at which the compounds volatilize depends on their physical and chemical properties. This can be determined with the Henry's law. Henry law is there. This Henry law will determines the extent of volatilization of a contaminant's liquid in the water, and this law states that the amount of any gas that will dissolve in a given volume or liquid at constant pressure temperature, it is directly proportional to the pressure that the gas exert above the liquid. So in chemistry, when we talk about this Henry law, this law will propose that the amount of any gas that will dissolve into given volume of liquid at a constant temperature is directly proportional to the pressure that the gas exerts above the liquid. So the this amount of contaminants will dissolve in the water, and this will be the amount of liquid that will be displaced is directly proportional to the pressure. So you can see that this is the equation for this Henry law. Pa is equal to Ha into Xa. So this Pa is the partial pressure of the compound A in the gas phase A. Ha is the Henry constant. This Ha is the Henry constant of a compound A, and Xa is the mole fraction of the compound A in the liquid phase in the equilibrium with the gas phase. So this Xa is the mole fraction, like how much pressure it has been put on the gas phase and the compound A in the liquid phase in the form of equilibrium with the gas phase, means how much mole fraction of the compound A in the liquid phase in equilibrium with the gas phase. So P is equal to Ha into Xa is a Henry law constant. This Henry law constant, this Henry law will discuss about the will say states that the liquid it will be displaced, it will be directly proportional to the pressure that will be put onto the liquid. So the partial pressure of the compound A in the given phase A, where Ha is the Henry constant of the compound A and Xa is the mole fraction of compound A in the liquid phase into the equilibrium with some gas phase. So now we'll discuss about the biological decomposition and chemical reaction. So first is the volatilization process will be there. Now the landfill gas generation inside the landfill can be developed by some biological decomposition and chemical reaction. So this chart I have already discussed in many lectures, like the 5 sequential steps and distinct phase. Phase 1 will be there. Phase 1 is like aerobic phase, and rest of the phase is anaerobic phase. Phase 2, 3 and 4. All three are the anaerobic phase. So in starting only they will have some amount of oxygen which they will utilize in the phase 1 only, and rest of the phase is all with the absence of oxygen condition only. So you can see that phase 1 is like it will be starts from the 80 because loss of oxygen will be there, so it will be goes down, so nitrogen will be there, and up to phase 4 very less amount of this methane will be produced. So you can see that this is the it is for the carbon dioxide. It is for the carbon dioxide. So carbon dioxide is also 40 to 60%, and this dotted line is for methane. The methane production starting in the starting phase up to 2 phase, like oxygen requirement is there. Oxygen is there, so methane production is very less. Up to phase 1, no methane is there. Up to phase 2, because less oxygen will be there, no methane is there. So up to phase 2, it is running very good. The landfill is running very good. But when it will enter into phase 3, where the oxygen is very less, oxygen will be there. In fact, no oxygen will be there. So that anaerobic condition can be formed. Anaerobic condition will be formed here. So in phase 3, anaerobic condition type has been created. So in this, you can see that CO2 and methane will be there, and nitrogen is also reduced. And in phase 4, only 2 gases predominant, that is methane, methane and carbon dioxide. Methane and carbon dioxide. So these two are there, that is methane production and carbon dioxide production. So this will represents the stabilization of waste proceed in the 5 sequential and distinctive phase. So some sequential phase will be there, where you can see that during the phase 1 and phase 2 aerobic condition will be there, and from phase 3 to 4 completely anaerobic condition will be there. So in completely anaerobic condition, only two gas are predominant, that is CO2 and methane. Like that in phase 4, CO2 and methane will be produced in more amount. So we'll discuss about all the phase in detail. In phase 1, that is the initial adjustment or an aerobic phase, where the microbial decomposition starts in aerobic condition with a certain amount of air, and it will be trapped within the landfill. It will be trapped within the landfill in phase 1. Phase 1. The landfill. So the microbial decomposition will start and it will be trapped inside the landfill. The soil used in daily and final cover is the principal source of aerobic and anaerobic organism responsible for waste production. So the soil that is used in the daily and final cover are the principal source of this aerobic and anaerobic waste decomposition process. So this C6H10, this is the carbohydrate will be there, is breakup in the presence of H2O. In H2O into this much of compound, that is again water, and H2 will be coming out. So this in the presence of oxygen, this aerobic phase will be started, and where the microbial decomposition will start the aerobic condition with a certain amount of air that will be trapped within the landfill. So this is the phase 2. Phase 2 is the acidogenic phase. In acidogenic phase, what happens? Oxygen is depleted and anaerobic condition begins to develop. Oxygen is going to be reduced during the phase 2. Phase 1, enough amount of oxygen is there. In phase 2, oxygen is going to be depleted. The amount of oxygen is going to be reduced and the anaerobic condition begins to develop, and the pH of leachate starts to drop due to presence of organic acids and elevated level of CO2. So the pH of the leachate will starts dropping. You can see this type of reaction takes place. Then first of all, carbohydrate is break up down into the carboxylic acid. Then again carboxylic acid is there. Then again this is the breakdown of carbohydrate to the carboxylic acid. So because of the pH of the leachates will starts dropping because of the presence of some organic acids and elevated levels of CO2. Oxygen is depleted. In this case, in the phase 2, oxygen is reduced and oxygen is depleted. Then this condition will starts. Phase 3 is the acetogenic phase. So in acetogenic phase, what happened? The production of significant amount of organic acid. CO2 is the principal gas that is being generated, and pH of the leachates drops significantly. pH will reduced. COD and BOD5 of the leachate increases significantly. COD and BOD5 increases. And some essential nutrients are also removed in the leachate. If the leachate is not recycled, the essential nutrient will lost from the system. So this type of reaction will take place. This is like the production of significant amount of organic acid, and carbon dioxide is the principal gas that is generated. pH of the leachate will drop significantly. COD and BOD5 of the leachate increases significantly, and many essential nutrients are there that can be also removed in the leachate. And if the leachate is not recycled, the essential nutrients will be lost from the system. Phase 4 is the methane fermentation phase. Like the organic acid and hydrogen gets converted to CH4 and CO2 by the process of methanogens or methane formers. The rate of acid formation is considerably doubled because the acid formation will be going to be increased, and the pH rise is more neutral value since the acids are converted to CH4 and CO2. The pH rise is more neutral values since the acids are converted to the methane and carbon dioxide. The rate of acid formation is considerably reduced. So this is the methane formation phase. Methane formation phase, that is CH4. Next phase is the maturation phase. Maturation phase is the final phase. Maturation phase is the final phase. That phase is also called as phase of decomposition. So in this decomposition phase, what happened? The readily available organic materials will be converted to CH2, CH4 and carbon dioxide. Rate of landfill gas generated will differences significantly, and the principal gas evolved is methane and CO2. And depending on the landfill closure measure, small amount of nitrogen and oxygen may also be there. In the maturation phase, where the only two gases are there, that is methane and carbon dioxide, and the rate of the landfill gas generated, it will be diminishes significantly, and the principal gas evolved are methane and carbon dioxide only. And the landfill closure measures, it will depend so mainly on the landfill closure measures, and a small amount of nitrogen and oxygen may also be there in this maturation phase. So this is about the phase of decomposition. So all phases of landfill, from where the gases has been generated, what are the chemical reaction and decomposition will happen inside the landfill, so that we can understand from which phase the methane is coming out, from which phase carbon dioxide is coming out. So in the maturation phase, in the final stage, this methane production will be there. So we can collect this methane from the tube wells, or we can collect this methane, and this methane can be utilized for the electricity generation, because this methane is having a very is a greenhouse gas and carbon dioxide also. So now these are the references of some of the textbook that I have followed for the study for these lectures. If you want to do depth study, you can go to follow these books, where you will get about all the information and all the depth analysis of these topics. So here I am concluding my lectures. This will be about the landfill technologies, what type of landfill technologies, the hybrid technologies that are now adopted in the foreign or in our country to collect the methane gas and for the electricity generation, to convert this waste to the fuel. So with the motto of converting waste to the fuel, this methane collection from landfill is very efficient methods, and because of that only the new type of technology has been developed for the landfill's gas collection system. And next we'll discuss, we have already discussed about the how this which type of chemical reaction happens inside a landfill, and when this aerobic condition will change towards the anaerobic condition, and what are the different phases of the landfill, and what are the maturation phase. Until the maturation phase, methane and carbon dioxide has been generated. So if we collect this methane and utilize this methane for the energy production, this greenhouse gas has been saved, and the emission is also has been reduced. So if you have any query, if you have any question regarding this lecture, you can write in the comment box, or you can directly mail me onto my given mail ID, shikha.pandy@gmail.com. So thank you for today's lecture.
Like, share and subscribe. Hit the bell icon for more updates.